Every year, according to official data from the U.S. Environmental Protection Agency, the United States generates over 9 million tons of electronic waste, most of which is not properly recycled. Investigations by AP News reveal that discarded electronics can release toxic metals like lead and mercury into soil and water, causing long-term environmental damage. And e-waste doesn't always come from large devices. Much of it starts with small items like old phone chargers we easily overlook. After safely removing the charging circuit from the adapter housing, I'll repurpose the board as a signal decoding component. At this stage, we use basic soldering to create 2 secure solder points on the circuit board, allowing for direct wiring connections. Next, I'll solder 2 electrical wires onto the 2 solder points we just created on the charger circuit board. After finishing the soldering work, I'll drill 2 small holes in the charger cover to route the newly connected wires outward, keeping them straight, clean, and free from pinching when the casing is reassembled. It may sound unusual, but an incandescent light bulb can work as a surprisingly effective signal receiver. Inside the bulb is a thin tungsten filament, a conductive metal wire with a length and structure that naturally responds to electromagnetic waves. When radio or TV signals pass through, that filament can act as a passive receiving element, converting electromagnetic fluctuations into a weak electrical signal. The glass enclosure also helps isolate and stabilize the filament, reducing interference from the surrounding environment. That's why, in many real-world DIY experiments, something as ordinary as an old filament bulb can deliver unexpectedly solid signal reception. This is a power outlet, and it works perfectly as a base for the antenna assembly. It allows direct connection to the antenna structure while also providing an easy point to attach the coaxial signal cable. Truly a single component serving two purposes. For those who may not be familiar, this is a coaxial cable, a type of cable designed to carry signals with high stability, thanks to its central copper core, surrounding insulation and outer shielding that reduces interference. This structure helps keep the signal clean and consistent. And right now, I'm connecting one end of the coaxial cable to the power outlet, which will serve as the connection point for the antenna system we're building. For the other end of the coaxial cable, I'll attach an F-type connector, followed by a 90-degree F connector, making the connection to the TV cleaner and much easier to handle. First, I'll attach the straight F-type connector to the cable, then add the 90-degree F connector to complete the setup. Alright, the DIY antenna is now fully assembled. On paper, everything looks good, but real performance is what truly matters. So instead of guessing, let's connect it to the TV and test it right now. Before making the connection, I'll check the TV first so everyone can see, just to keep everything clear and transparent. In just a few seconds, the TV picked up the broadcast signal. That's a very promising result, but to judge long-term stability, we'll let it run a bit longer and see how it holds up. After waiting for a while without noticing any issues, I decided to disconnect it and plug it back in for another check. After multiple checks, connecting it, unplugging it, and plugging it back in, the antenna remains stable. To me, this isn't just proof that a DIY antenna works, but a reminder that old items still have value. Sometimes all it takes is a different perspective to turn something forgotten into something useful. DIY isn't about perfection, it's about making better use of what we already have. If this video makes you hesitate before throwing away an old electronic item, then it's done its job. Thanks for watching until the end, and I'll see you in the next DIY project.